Hello everyone, bienvenue à tous. Welcome to the Olbgis conference. I am very proud to be one of the first speakers during this conference, which bring out a lot of GIS experts, but also IT experts and other subject area during this next 3 days, where we have to dive into GIS to know how to do new business with GIS, to know how to optimize existing GIs we have in our company. But before all, I hope that you and your family and your loved one, you are feeling good. You are feeling good in this period marked by the pandemic, the COVID-19, which killed many people in our neighborhood. I'm gonna talk with you about a very passionate subject, GIS for utility. And today we're gonna talk about how to optimize our utility process with GIS. During this conference, we're gonna talk about discovering utilities company, what is GIS, the GIS in utilities, and for sure how to optimize your utility using GIS. Before to move inside the subject, allowed me to talk a little bit about me. I am Marcel Cedric Ebele, IT engineer background. Today, I am head of digital application and also a promoter of an IT startup called Insight Lab Co. I am about 12 years on IT business service, working in many subject areas such as customer relationship management, the metering system, prepaid technology, asset and work management, workforce management, and for sure, GIS. A short advantage I have is that I start working not in IT department, but in a distribution department where I work closely in the business. I introduce myself as a digital transformation evangelist, data manager, GIS ninja, and a BPA senior. I got strong experience on ArcGIS technology such as mobile desktop server, in web technology talking about the mobile application, the web application, in the middleware, the APIs management, enterprise bus solution. I also got experience on IBM Maximo. I contribute in the implementation of of Maximo in more than one company. I got also experience in OpenGIS technology such as Quantum GIS. This morning we're gonna talk about utilities. An utility company is a public organization which provides service to citizens. There are too many utilities company, but the top four are telco, gas, water, and electricity. There's a structure whose service is vital in everyday's life. As we live in an era of digital revolution, whose magic word is connected mode. This could not be possible without 3G, 4G, and 5G provisioned by telecommunication. Therefore, coverage should be everywhere and at all times. Besides, a conference like this is highly dependent of this service. Yes, You cannot be connected now and following this conference be without a network connectivity. For heating and cooking purpose, gas is very important in everyday life. The third one is water. No one can live without being hydrated. Drinking is as important as breathing. So the need for access to running water is one of a municipality key need. Electricity is an integral part of our everyday life. It is the level on which technology is based. Life in the night could not be possible without electricity service. This company, this utility has four main processes in common. The first one is the generation. The generation, there is a place where the energy is produced. Then comes the transmission. Because customers are not living where the generation is done, the transmission transport the service from the generation location to customer suburb. The third one is distribution. The distribution is where the service is supplied to end user. It is also where the service availability is managed. And the fourth one is the commercial. For sure, this company have to build and provide customer care. What is the GIS? We can introduce the GIS like a system for collection, processing, analysis, and sharing geographic information. It's the kind of system with many layouts where we just overlap one layout to the other. So today the GIS is studied in the schools, in many university, because all of us we are living everywhere and understanding where something happened help to understand better the situation. The GIS is a system with five separate layouts which are independent each other. Here we talk about hardware, which is the bottom one. Hardware because there is a need to get servers, there is a need to get workstation, and for sure mobile devices to work. After comes the software layout. At this level, we need application we will use to to capture data, to trade data, and to share it with many other people. After we have the data in all form, we can start by satellite imagery, all vectors data, spatial data, and also relational data in tabular form, Excel sheet, or text format. Analysis come after because the data is not the same, don't have the same signification in various subject area. We can take the example of one man. You are a man, you are a married with your wife, you are a father with your children, you are a neighbor with your neighbor, you are a colleague with your colleague, but at the end of the day, you're still a man. So when you capture one data according to the subject of interest, the analyze can bring more insight. And the last and the key important layout is people and process. We cannot work without people. We need trained people to maintain the GIS system. We need open people to project the GIS, and we need process to make sure that the the system is not people dependent and can live without people. One of the big difficulty of the GIS is the implementation. And we can say that when planning a successful GIS, you must think first about what you want from it. Everything else you do comes from that vision to ensure that the GIS will ultimately work towards serving some useful and important purpose. Start by considering the strategic purpose of the organization within which the system will be developed. What are the goals, objective, and mandate? Remember, organization adopt GIS at the assumption that it will make their work easier and cheaper to do or better for the customer. So you have to examine the organization strategic business plan. The GIS planning process begin with a review of your organization business plan. You have to set up the mission, the principle, the goal statement, the program, an employee development and support, the public interaction, and the organizational review. Anyway, GIS will impact the business strategy of the organization. It is estimated that in modern business, 80% of all information has a geographic component, a location, above or under the surface of the earth. Today, many utilities are using GIS. They are using GIS for many subject purpose. In the subject of study, design, and develop and new network development, we have the demand and load forecasting. The creation of the future state of the system based on demographic and local forecast. At the level of planning, project what equipment will exceed their rating. For example, which transformer will exceed its normal rating in the next 10 years. We can display this on the map. We can find another insight from the map and reallocate connection on less loaded transformer. This can be done in electricity area, in telco area also. At the level of design, we have to project new component of the network in an interactive map to see how change will be. Instead of doing the design on CAD file or CAD system, this can be done directly on GIS, and any change of component will be immediately reconciled with the area of design such as component asset are all together in a same database. In the commercial area, for reading and billing, GS helps today to locate customers, helps to manage routes and itinerary for readers. The GIS helps also today to determine pattern for meter readers, and it serves as a monitoring tool for field activity such as inspection and billing. The GIS at the level of call center is the heart of utility because we can provide heat map per inquiries for outage or simply for each event. For the revenue protection or losses, we can visualize area plagued by energy theft, visualize the mismatch between known usage and actual consumption. So a kind of balance between the energy inject or the quantity of service provided by one transformer versus what is billing can allow you to see where can be some mismatch and for sure energy theft on the field. At the level of data management, GIS allow to manage the asset data. The utilities need to set up in one pieces data coming from all other sources. At this level, we have to set up the enterprise asset management, the work management, the real-time data, the metering, the customer management, and the network analysis system. So the new network model can be set up to, to allow the master of the asset life cycle. We can also assessing performance because we have the asset condition history for each asset. We can predict the performance of the whole system. Talking about the optimization of the life cycle, the heart of asset management is the optimization of resources. How the GIS optimize the entire asset life cycle by centering around location. We can also see how to capitalize, how to get the ROI versus the risk, the performance, and also compliance. The last subject area is the workforce management. At the level of outage, we can link one node to downstream equipment and customer to down to downstream equipment and customer. This helps to manage easily and accurately one incident on the field. Mobile apps allow workers to find easily location and report action performed in real time. You don't have to wait that your teammate return to the office before to have information. You can have the information when he is collecting it in real time on the field. And the last level is the safety and situation awareness. With GIS today, a customer is able to locate an incident, and from the office we can send crew to the position. We can monitor the logistic and the lift of our crew until the destination where they have to work easily. So this is the use today. This is not all the use case of GIS, but there are some critical I got in my mind and I can share with you. I know today many utilities are using GIS as is, and this help a lot. This help a lot because it was very difficult to work only with papers. Today, with the numeric evolution, with the use of computer, we have centralized database where everyone can sit and sharing the same information. Everyone can sit and discuss about how to improve the business using the GIS. The question is, how can I optimize my business using GIS? I have GIS. I use it for many process once have been identified in this presentation and other no. But how can I? Jack Dagemont says the application of GIS is limited only by the imagination of those who use it. What is your imagination concerning GIS? How do you think the GIS can help you more? It helps today, but how can the GIS help you more in your business? I'm gonna introduce you one pattern. Public service infrastructure are built so that one piece of equipment is connected to another depending on the flow of the service it delivers, whether it is telco, electricity, gas, or water. This new pattern, simply called network, bring out a hierarchical relationship between nodes, brings also the concept of streams, where other IT applications are limited to link entity with attribute. GIS enable the geometric connectivity link based on the location of asset and provide more insight using the downstream and upstream approach. It's a kind of a tree where the root is the whole father, and at the level of each branches you have a father, the son of the father, the son of the father, a kind of hierarchy. And the downstream is what is below one node, and the upstream is what is beside one node, coming from the root. So, for example, talking about the downstream approach, the downstream can help to identify, then notify customer impacted by the bursting of the water turbine, because you know not only by attribute but also by connectivity link, you know all the meter which are connected to one transformer. So when there is a incident, as you see on this map, you have a blue selection, and you actually know exactly all the matter concerned by the interruption. Another use case is in case of failure or decrease of 3G 4G signal, we can know, we can identify all the BTS which can cover impacted customer. The upstream approach help you to know what happened at the top of one node. For example, with demographic and spatial analysis, we can determine suburb of delinquent people for revenue protection. What happened? Because you identify one, two people who is delinquent, which not normally paid, you can find out the social status of these people. And once you have the social statue, we can reconcile the suburb on which this kind of people belongs. Then we can identify that this kind of suburb in the demographic and social dimension can be identified as delinquent suburb and bring at the level another action. Concerning the upstream also, at the level of call center, when you receive one, two, three calls from different customer saying that there is no light in their house or claims about the quality of network, the GIS can help you using the network pattern to identify the transformer which delivers energy to this customer, and for sure to identify all other customers that can be impacted by the decrease of service quality, and you can inform them and start also work for maintenance to bring back the good level of service quality. There are too many use cases that can be pulled out with the principle of a network, because the key is the network. The key is the connectivity between entity. This connectivity belongs to the geometric connectivity and for sure the location of this equipment on the field. So this is where the GIS can bring more insights than just exploring attribute data, because you represent in graphic dimension entity based to their location. This by default build a geometric connectivity between this entity and can bring more insight with the downstream and upstream approach. So now, how do you see your GIS will be? Today, our GIS provides a new complete network model that bridge all this technology, consuming critical information from many sources to provide a complete picture of the utility system for electricity, for telco, for water. The GIS today, the ArcGIS approach, state the GIS by three big components, big three big system: a system of record, a system of engagement, and a system of insight. At one level, there is a data model, there is a repository for asset location and the relationship to surrounding. A system of engagement is where people are working, getting information from social media, communication in real time, keeping stakeholder. This is the level of business. The system of eSight also for powerful analytics. ArcGIS enable data exploration and understanding. Maps and apps deliver asset information and insight to the entire enterprise. ArcGIS for Esri bring out an integrated ArcGIS utility network, which allow you to create and update entity that model each type of distribution material, identify how the entity are connected to the network, trace how resources, gas, water, and electricity, for example, pass through the network, provide an operational view of how all the dynamic appliances in your distribution are currently configured, analyze how the network is affected by real events such as thunderstorm blackout or equipment failure. So today, how do you think you can optimize the GIS in your utilities? The GIS can also be used by small and medium enterprise. We don't have a data server with many servers to maintain. One big structure of software as ArcGIS big database. Today, we have many solutions on the cloud. You just have to buy each month and use the GIS solution on the cloud, which will allow you to know where your customer are, to share information with your stakeholders, to share information with your colleagues. You have many applications open GIS today which are existing, which can help you to deploy easily a GIS solution in your company. Today, ArcGIS with the recent collector and ArcGIS Explorer can help you with the integration with Google Map to find easily and navigate also using Google Map geocoding until the location you are looking for. So there are many use of GIS today. You just have to imagine, as Jack said, you just have to imagine what you want. All is about geography. All is about location. The science of where start by where happened this. How can you how can we use this response to improve the business? So um, uh, I am very proud to be again one of the first talking on in this conference. I hope that um, uh, you found many objects of interest during this presentation. It was very short, I know. There are many subjects that can be developed in many hours, but this was just a kind of synthesis form to present you the GIS, the use on in utilities, how we can improve it using a pattern of network, because all objects are connected, and at the end, what can be the future of your GIS. So for now, I am ready to receive question coming from you, but not only question, remarks also, contribution. We are one community. We are one community here in Africa because I'm African. I'm working also in Sub-Sahara. We have many implementation of GIS, but we have to move forward. GIS cannot only stay as a simple software that we use. We need to use GIS to optimize our business. We just have to think out of the box. Think out of the box. Many people experiment what we are experimented today. And I am sure that by sharing our difficulties, by sharing what we want to do, we can find simple solution that we can implement and perform more our business, bring more value to our business. And this is not only at the level of GIS, at the level also of all IT solution. Just be open, just share what you want to do, what are the question, what the situation you are facing. And I'm sure that even during this conference, we can bring out solutions that can help you easily. So this brings me at the end of this presentation. Thank you very much. Thank you very much for attending. Thank you to all the experts, all the GIS experts around the world. Thank you for the organization, Olbgis team, Diana, all these people which are working to make happen this conference. So now I'm waiting your question. Thank you. Bye bye. See you soon.